Okay, now we have the BVP, boundary value problem, or second order linear differential equation. So how we want to know? This is the second order linear differential equation. So we have d squared y dx squared. Okay, right. So now if we want to solve, it depends on the boundary condition given. Sometimes the boundary condition we have the derivative, sometimes we don't have the derivative. So that's why if we want to solve the BVP, it depends on the boundary condition given. For example, we have this BVP for this range, so we need boundary conditions. So first at the x naught and another one will be at the xn. Okay, so this is without the derivative, but sometimes we have the boundary condition with the derivative, so it depends on the condition. So to solve the BVP, we will apply finite differential method that we have learned in chapter 4. So to solve we will apply our formula by using the centered formula, 3-point centered difference. For example, for the y prime, we are using this formula. So you can look, you can find this formula in the list of formula. So y double prime, so we are using this formula. So both this formula is 3-point centered formula. Okay, alright. So for the first case, or for the first boundary condition without derivative, for example, when you have ya equal to alpha, yb equal to beta. So if we look at this both condition, we don't have the derivative. So this is for the first case. For example, this one. Okay, for example, given a second order differential equation with the boundary condition. Okay, so obviously we know this is the Dirichlet. Dirichlet means no derivative. So the first question, by using the finite differential method, show that the different equation for the above can be written as blah blah blah. Then by using the equation in part 1 and the boundary condition to obtain a linear system. And then, okay, alright. So let's try. So first we need to use the centered formula. Centered formula, so this is y double prime plus 1 over x y prime minus y over x squared equal to 0. Okay, so for the first question, so by using the 3-point centered, okay, alright. And maybe the first step we have to multiply this equation by the h squared. Zero. Okay, now rearrange yi minus 1 first. Okay, so let's say we want yi minus 1, we have 1 and then negative minus then and then for the yi and negative. Okay, so negative yi, so plus yi, so negative should be negative. Sorry. yi negative positive and the last one and positive. So we have done this part and this part, so we have yi plus 1, so 1 plus h over 2xi, yi plus 1 0. So this is the formula after we apply the centered difference. Okay. So now the question number 2, by using the equation in part 1 and the boundary condition to obtain a linear system in the form of a y equal to b where our h is equal to 1.5. Okay, right. So first for the question number 2, so you have to construct this timeline because this one is very important for you to know which y that we need to find, right? So x naught equal to, obviously from the boundary condition, from the first boundary condition, so y naught is equal to 0.8. x1, so h is equal to 1.5 just now, so equal to 3.5. x2 6.5 plus 1.5 8. Okay, so obviously y4 is equal to 0.001. Okay, right. So let's see if you have the Dirichlet boundary condition or the condition with no derivative from this timeline, from the boundary condition, so you will have the answer for the y naught and also yn. Because this one with no derivative kan, this is no derivative, so from this condition obviously you will get the answer for the y naught and also yn. So for your task is you need to find y1, y2 and also y3. Okay, so 3 y, so the equation that you need to find is also 3. Let's say this one is y1 and also y2, so you only need two equation. Depends on the value of y that you need to find. So for this case, we need to find y1, y2 and also y3 kan. So 3 value of y, so you need 3 equations. So back to the equation that we have applied just now, we have done just now. Okay, so we want to find y1. Okay, y1, so you need to ask yourself, so what is the value of I that you need to use? Okay, now we have yi minus 1. Let's say when you start your I equal to let's say lah, your I is equal to 0. Okay, here you will have y negative 1. But from this timeline, we don't have the value at y negative 1. Okay, that's why for this case, you need to start your I with 1. Only then here you will get y 0. Okay, so you need to start your y with 1. So let's say I equal to 1. H just now is 1.5 kan? 2x1 y 0 0. But we also have the value of y naught. So y naught is 0.0008. Okay. Minus this one should be 0.8 only. Okay. Again. 0.0063 plus zero. So let's say if we rearrange, so I put to the left hand side, so we will have negative 0.0063. Okay, so this is as your first equation. Okay, now continue for I equal to 2. To x2 this is your second equation. So we need another I, because we need because the first, our intention is we want to find y1, y2, y3 kan. So of course we need three equation. So another one, when we learn our I is equal to 3. X to 6.5. Equal to 0, but we have the value of y4, so y4 is also equal to 0.001, right? Mine is like this now. Negative 0.1234. Our third equation. So again, 1 plus 1 point. Do we square here? No, right? Over 2 plus 1.6.5 times 0.001. Okay, right. Use equation to obtain a linear system in the form of AY equal to B. Okay, so we need to put our answer in matrix form. So this is not complete yet, so what you need to do is you have to write your answer in matrix form. So AY, for the question 1 we have y1 so it should be y2, y certainly y, y1, y2, y1, y2, y3, y2, y3. Okay. Okay, so this is the answer. Yeah, let me check. Negative 2.1837, 1.2143, y2. So this is the complete answer. So the question number 3, write the Gauss-Seidel formula. So this one you refer to chapter 2 lah. Okay.